everybody, and welcome to your maths learning today, and happy Friday. Well done to all of your learning this week. So today we've taken our little steps to develop our understanding of equivalent fractions. We did based on just the diagrams and using pictorial representations to really support our understanding. Then we moved on to using our knowledge about the parts with the denominator and the numerator, the relationship between those. So today is just a chance for you to show all of that off in your Power Maths session, okay? So let me share my screen with you. Now, something that I think we need to have a little bit of a practice of, and what I've set you for your Fluency Rewind this morning, is using your inverse, okay? Because it's a really important skill when we're looking at the relationships between the denominators and the numerators, okay? So what I've done for you here is you can see, now I really do apologise, but it's very tricky to find a division symbol on computers. You have to do lots of little steps. So it's just, I just leave it blank and then sometimes forget. So what I'm going to do, just really quickly, put them in for you. Okay, there we go. Might have to keep this and just reuse it. So you can see, the first one here, I've given you some multiplication sentences. Can you then use that knowledge of their fact families in the inverse to work out what the answers would be for those division sentences underneath? Then I've got some missing number problems. So you might need to, if you wanted to draw using your knowledge of a bar model, to just think about your wholes and your parts. So 42 is my whole. I'm dividing it in, I don't know how many parts, but I know that in each part there is 7. Okay, so how many parts do you need to use your inverse there to work out what that missing number is? Okay, so have a little go at those. So think, if you've got the whole, you are probably going to have to divide. If you haven't got the whole, you are going to have to times. Okay, so think about what the whole is. Okay, so have a little go at those questions then for me, using your knowledge of inverse, okay, and thinking about what information you have. Do you have the parts? Do you have how many is in each part, or do you have the whole? Once you've had a go at those, come on back to see what we're going to be doing today. Brilliant. So hopefully you've had a go at that now. If you haven't, make sure you have a go before I start carrying on telling you all of the answers. So what we're going to do, where is my pen? Let me just get my pen. There it is. I'm going to do it in red so you can see. So I know here that 2 times by 5 is 10. So using my knowledge of fact families, I know that 10 divided by 2 must be 5. Okay? 11 times by 6 is 66. So 66 divided by 11, what's that other part of that number sentence? Is 6. Okay? This one here, I've got 42 divided by something equals 7. Okay, so I know that 42 is my whole. So I've got my whole. So what I can do to get my answer is I can divide by that, my answer, and it should give me how many goes in each part. So I'm just swapping that multiplication around. Okay, so 42, how many 7s can I go into 42? 7, 14, 21, 28, 35, 42. Fantastic. So that was 6 lots. So I know that 6 times by 7 is 42. So 42 divided by 6 is 7. Okay. Okay, 8 times something is 32. So I can use my multiplication here. So 8, 12, no, 16, 24, 32. So I know that 8 times by 4 is 32. Okay, something divided by 9 equals 9. So I've got my whole here. Okay, I'm going to use my inverse there because I've got the 2 numbers that I know make that whole. And if I times them together, it will give me my answer. So 9 times 9 I know is 81. I'm going to divide that by 9. It should give me 9. So thinking about those fact families. Okay, 56 divided by 4. Now, if you don't know that straight away off the top of your head, you can use some of our old learning. You could simply use your little quick short division here. you're not very confident in your 4s, I know I can make one group there and there will be 1 10 left over. So now I've got 14. Oh, I did think that's not going to work, Miss Athens, because it's 6, not a 4. 16 is 4. So I know that 56 divided by 14 is 14. 56 divided by 4 is 14. Sorry, guys, going a bit mad here today. Okay, so hopefully just a little bit of a refresh of how you can use your division, your multiplication to find out those missing numbers. Hopefully it's just woken your brain up to use today. So let's have a look then. What are we going to be doing today? We're going to continue our identify, name and write equivalent fractions. We're going to show this off in our Power Maths book and finding lots of equivalent fractions. So today then, this is a revision, a rewind. What I would like you to do is just to simply tell me whether these are equivalent or not. So you'll notice that this one, I've given you the diagrams and the fractions. This one, I've just given you the fractions. So are they equivalent? So it's asking you to use those different knowledge. And this one, I've given you a fraction and a diagram. So are they equivalent or not? Simply, yes, it is. No, it is not. Okay, extra little step, you can prove it to me. Okay, if you want to challenge yourself a little bit further, you can prove it. So how do you know that they are? So this one, you might want to draw the diagrams. This one, you might want to do a little explain. And this one, you might want to draw the fraction and use your top and bottom denominator and numerator relationships to show me. Then once you've had a go at that one, can you convince me? So Jenny has coloured 2 grids to create an equivalent fraction. They are shaded in the same shape, so they are equal. Is she correct? Explain her answers. Okay, so that's a little extra challenge if you think, I've really got the hang of this, Miss Tyson, and I'm going to show off how amazing I am, and I'm going to send you this convince me. Okay, brilliant. Come on back when you've had a go at that. So hopefully you've had a go at that now, and you've put yourself to have a go at that convince me. So let's see how you got on. So let's have a look at this first one then. So this first one, I've got 10 12ths and I've got 5 6. Now, I've used the diagram here. So there look pretty even to me. So I think that that one is true, but I'm just going to double check it by using my knowledge of the denominator and the numerator, the relationship. So I can see here that 12, I have divided I've got less parts now, so I've divided it. I've actually grouped. How many have I grouped together at each time? I've grouped 2 together to make one of those parts. So I've divided by 2, which is now giving me 6 parts. So the top number should be divided by 2 to give me 5. So I know that yes, that is equivalent. So well done to you if you got that right. Right, this one then. So this one I'm going to use my knowledge again. See if it's equivalent. I'm going to see what's happened to my parts of my whole. So here I started with 14 parts. I've now only got 7. So what is the relationship between 14 and 7? How many times more or less parts have I got? I've got 2 times less. So I've divided them by 2. I've put 2 of those smaller parts together to make one larger part. So then hopefully, if this is correct, 8 divided by 2 should be 4. So yes, that is equivalent. So well done to you. You could have drawn that to prove it to me. Right, this one here then. So the first thing I'm going to have to do here is think about this fraction. So 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 parts that make up my whole, and I have 4 of them. Now I remember that rule that if this is divided by 2, if this is half, your numerator is half of your denominator, then it is an equivalent fraction to a half. So 8 divided by 2 is 4. So yes, they are both showing me a half. Fantastic. Okay, so well done to you if you got those correct. You are smashing our equivalent fraction knowledge. So well done to you. Convince me then. Jenny has coloured in 2 grids. So she's coloured in exactly the same shape. So is she correct? What has she completely forgotten about? She has completely forgotten about her knowledge of fractions using her denominators to see if they are equivalent. So let's have a look then. Let's see if she is correct. Because she might be correct, but it will definitely just be a lucky guess. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need to remember that it's not about it covering the same shape. It is, in fact, thinking about the amount of that whole that has been shaded. Okay, so is Jenny correct? Explain your answer. So how many parts have been shaded here? We've got 6/12. And we've got 1, 2, 3, 4, 6. So let's check it. So this one here, what has happened to my parts? I have got divided by 2 because I've gone to a smaller number of parts. So 2 of those divided by 2. Yes, so 2 of those have joined together to make 1 of those parts. So you can see they've also tried to trick Jenny there by just turning it on its side. So you can see that 2 of those parts have joined together, and now my whole is made up of 6 parts. So if it is an equivalent, I should be able to do the same here and get 4. 6 divided by 2 is not 4. So the correct amount of parts have not been shaded. Extra question, and well done to you if you worked out that actually how many parts should have been shaded for them to be equivalent. You should have only shaded 3 to give them equivalent fractions. So well done to you if you spotted Jenny's mistake and if you were able to correct it. So well done to you. Fantastic. So as I said, our rewind is just a little bit short and sweet today because you have done some great learning this week. So now it's time to apply it in lots of different situations. Okay, so we're going to use our Power Maths books for this one. So we're on page 42, okay? And it's going to accumulate everything that we've done over the last 2 days. So you will see question A is simply giving you the fractions. They've already done the diagram for you. So nice and easy one, that one is. So you can use that pictorial representation to tell me what an equivalent fraction is to a half. Question B is just like we were doing on Wednesday. They've given you the original fraction. So they've given you the 2/3 of that whole. Can you draw lines and split those parts a little bit further to find some more equivalent fractions? Okay, so just like we did on Wednesday. So try and find 3 different ways that you could split them. But remember, your parts must be equal. Okay, so I can't just randomly draw some lines. You need to make sure that all the parts that you are splitting it into are equal, the same. Okay. Question C, you can shade the diagrams to match each fraction. So here they've given you the whole. Can you then split that into the different parts and shade the numerator? That's just checking your fraction knowledge there. But again, remember, your parts need to be equal. Question 2 is then using our knowledge of the relationships between our denominators and our numerators. So you've got 6 ones to have a go at there. So they've already given you the arrows, which is really, really kind of them. So thinking about what that relationship is. 3, they've then given you 4, A and B. They've given you 4 equivalent fractions. So you need to use your knowledge to see what has happened to each of these equivalent fractions. Okay, so I would suggest drawing on your arrows and the operations that you've done to help you with that one and B. Question 4 is, can you ever have these 2 fractions, sorry, I'm going to start again. Are these 2 fractions equivalent? Ambika has had a little go at that. Is she correct? And then if she's not, can you explain what mistake she has made? And then can you prove it to her using a calculation or an array? Okay, so make sure you're proving it there. So once you've had a go at this, then you've got your challenge. So here they've given you some number cards. So can you use your knowledge about the relationships between these numbers to pop them into the position of their denominators or their numerators? So there's 4 different ones to have a go at there. And then it asks you to pick out that pattern. And as always, once you've had a go at all of those questions, remember, get as far as you can. I really do want you to try and push yourself today because we've done lots of learning leading up to this. So get as far as you can and try and push yourself to try and reach that challenge. But if it is a little bit too tricky, do not worry about it. Finally, then, you'll reflect. and you show 2 different methods that you could use to find equivalent fractions to 6/18. So they've given you that fraction. They want you to find 2 other equivalent fractions using 2 different methods. Now, we've done 2 different days of learning on our equivalent fractions. So there's 2 different ways that we have already given you there. I hope you have a lovely day and a lovely weekend, and I'll be back with you next week to continue with your fraction learning. Goodbye.